All right, we need to get into something called dimensional analysis. That may sound scary, but dimensional analysis is literally just a way of doing mathematical conversions from one unit into another unit. Okay, that may be city blocks into square miles, or whatever it may be, miles into meters. It's just a simple way of converting the unit of one value into something else. Okay? Now, the way we're going to do dimensional analysis or conversions is going to be very, very consistent, very uniform. The reason is I need to show you a pattern that I like to teach that makes dimensional analysis much, much easier. Now, the reason why we're doing it early in the semester is not because I need you guys to know how many square miles are in a city block or whatever, conversion I'm thinking of, is because really it's a preview for an entire unit which we'll be going into later in chemistry called stoichiometry. Stoichiometry is an entire unit involving math and conversions involving moles. So the more we can understand and the better we are at metric conversions or dimensional analysis at this point of the semester, then later when we get to stoichiometry, the easier it's going to become, and I promise you that, okay? So where we are in the note packet, this is page 10. This is directly below the guess method, which I put into a previous video. It's, again, dimensional analysis using conversions, okay? So at the very top, it says a conversion factor. A conversion factor is basically something that is the same but using two units. For example, I could say 1 week is 7 days. Is there any difference between 1 week and 7 days? Absolutely not. They are exactly the same thing. One just has a unit of days. One has a unit of weeks. 1 week is 7 days. That is undeniable. I could use those interchangeably, but sometimes I need to be talking about days. Sometimes I need to be talking about a week. That is a conversion factor, okay? I couldn't say days per month because that's a little more complicated because, again, those vary depending on what month you're in. But days and week, well, that's very, very consistent. It's reliable. I can convert between those two, okay? So that's a conversion factor, something that is the same exact value but may be shown in two different ways with two different units, okay? Another very easy example would be there are 12 hours in a day. 12 hours, or 24 hours in a day. Wow, it has been a long day. 24 hours in a day. That, again, is consistent. Whether we're talking about days, it'd be 1. Whether we're talking about hours, it would be 24. But the exact amount of time, the amount of duration in 24 hours and the amount of duration in 1 day is exactly the same. That is a conversion factor. What we have here, again, it says at the top of your screen, converting, the unit to be canceled is placed on the bottom of the conversion factor. The unit to be canceled is at the bottom, okay? And I will show you what I mean in a minute, okay? So number 1 and 2 and 3 are actually fairly advanced. They kind of talk about some silly things like cars and animals, but as far as where I would like to start is number 5, because number 5 kind of shows you more of the process as we work our way up to actually a little bit more complicated examples, okay? So I'm going to go ahead and start with number 5 for a reason that, again, hopefully will become clear to you in a minute. All right, so what we have here is 5, how many seconds are there in 24 hours, okay? So using the guess method, we have the given, in this case, 24 hours. We have the unknown, which is how many seconds. We have the equation, well, guess what? It's dimensional analysis, and you'll learn that here. Then we have the substitution, which is the conversion factors, and finally the solution, which is us solving the problem. So what I'm going to start with is us putting in the given. We have 24 hours, okay? Now I'm going to do this weird thing that's going to look a little bit funny. We call that either a picket fence or a railroad track. Now you're saying, what the heck? What it is basically is it's going to be a fraction times a fraction. What I have here and what I have here are identical. The only difference is the top one is going to become a little easier, and you'll see as these problems get a little longer and we have to go through multiple steps, you'll start to see why we use the top method as opposed to the bottom. But 24 hours, you could think of it as being over 1, and then we're going to multiply it by the next thing, which is after the vertical line. All right, the most important thing you need to understand is the way we're going to do this is Let's see. Why does this look a little different from the earlier day? I don't know. Things keep changing on me, and this is getting frustrating. Nevertheless, what we're going to do is we're going to take this unit, and we're going to carry the unit to the bottom. Remember, I just said that the unit that needs to be canceled out is going to be put on the bottom of the conversion factor. The conversion factor is what we are starting to build at this very moment, okay? Now that I have that, what I'm going to do is I need to think of a conversion factor that I can convert hours into that is going to go above hours. Now, what we're trying to get to eventually is going to be seconds. But I don't think I know how many seconds there are in an hour. Maybe some of you guys could do it in your head, but let's do this concretely on paper. What I do know is the number of minutes in an hour. Right? I know how time works. I know how many minutes there are in an hour. But that's not where we want to finish, because the question, the unknown, is seconds. So guess what? We're going to do exactly what we did before. We're going to take that unit and carry it back down to be canceled out. Okay? So, sorry, that's just a continuation. I don't want to, let me take that off. I don't want to confuse anybody. So minutes is now on the bottom. Okay, just like I did before, I need to think of a unit that I can convert up into from minutes that is equal, or at least something I can convert into. I know how many seconds there are in a minute, and therefore that is going to be a legitimate conversion factor that I'm going to be able to use. Now, if you notice, if we follow this weird zigzag formation, hours will cancel with hours, minutes will cancel with minutes. So guess what? Our answer is going to be in seconds, which again is exactly what they want us to solve for. So that's perfect. Everything cancels out but the unit at the top right, which is what your answer is going to have. All right. Now what I'm going to do is put in the conversion factors, which are in fact numbers. So I know that there, for every 1 hour, there are 60 minutes, right? And for every 1 minute, there are 60 seconds. So there we go. There's our dimensional analysis conversion of hours to seconds by going through minutes. We had to cancel out hours, then we went into minutes. Then we had to cancel out minutes to get to seconds. Then we put in the conversions of how many minutes are in an hour, how many seconds are in a minute, and then we're going to calculate it. Notice I did the numbers last. Please do the numbers last. In my experience, I've noticed when students try to put in the numbers while they do the units, they make a lot of mistakes. Trust me, if you do the pattern with the units first, then go back and do the numbers, it's significantly easier. All right, the way I'm going to do this with the math and calculate is what I don't want you guys to do is multiply across the top, get some number here, multiply across the bottom, get some number there, and then re-enter the top into the bottom number in your calculator and get the final answer. That is too many steps. That is too complicated, too hard, and mostly takes up more time. And what I care about is it's going to introduce the possibility of error. The more times you write down a number on paper and then put it back into your calculator, you're really introducing too many opportunities to make mistakes. Okay, that's just human nature. So I'm going to show you a way to calculate this entire equation in one step, and I'm only going to hit the equal sign once. Okay? Again, therefore, reducing the chances of mistakes. So what I'm going to do is I'm going to take the 24 at the top left, and I'm going to multiply it by every single number across the top. So 24 times 60 times 60. Not even going to bother hitting equals. Okay? Then every single number that's on the bottom, I'm going to divide by. So I'm going to continue. Divide by 1 equals. There's the first time I've hit the equals, and I have my final answer. So again, that is 24 times 60 times 60, divide by 1 equals. Okay, we get the answer of 86400, or 86,400 seconds. That's how many seconds there are in 24 hours. Not surprisingly, none of us had that memorized. Now, I lost my train of thought. I had something else to say, but I forgot. But again, doing it in one step is easy. This is what I was going to say. A lot of people will tell me, Mr. Wyatt, you don't have to divide by 1 and divide by 1. And now I know that, but I'm going to go ahead and tell you the exact process. And the reason is because those are not always going to be 1s on the bottom. And if I say it consistently every single time, then you guys are going to be better at doing it correctly each time as well. So that's how to convert the number of seconds from 24 hours. Okay? So what I'm going to do is I'm going to go ahead and go up backwards, which is, I know, a little ironic. I'm going to go ahead and go backwards, and we're going to go ahead and do number 4 next, and then try this one. It's a little bit different, perhaps a little bit harder, and it's great practice. So number 4 is actually a real chemistry problem. It says, how many grams are in 2.33 moles of water? If, here's our conversion factor they're giving us, if 1 mole is 13.02 grams. Now, if you don't know what a mole is a quantity. If we say 2.33 moles of water, that is an amount. Now, I can't show you what that is because I can't hold that much water, but it's just an amount, okay? So we're converting quantity to a mass. So what we're going to do is we're going to take the given. The only number given to us to start with is 2.33 moles. Mole is abbreviated MOL instead of MOLE. I know that's very silly, but for some reason the abbreviation literally contains one less letter. So MOL is 2.33 mole. All right, following the exact same thing that we've been doing is I'm going to then take my unit and move it back down to the bottom because, of course, what I want to do is cancel out moles, not continue with moles. Okay? Then I'm going to go up and I'm going to convert into something that I know is equal to a mole, for this case, of water. All right? Because they gave us in the box that I boxed is 1 mole is equal to a certain number of grams, that tells me that I could be confident in converting directly from moles into grams. Okay? Again, if they did not give you that information in the box at this point in the semester, I would not expect you to know what the conversion is. Later you will. So, but at this point, moles are going to cancel out. We can convert moles into grams because they gave us the conversion factor, so that tells me my answer is going to be in grams. Okay? All right, now all I have to do is, again, put in my conversion factor. It tells me that 1 mole is equal to 18.02 grams for water, specifically for water. All right, so I'm going to take my calculator. I'm going to do this in one simple step. I'm going to do 2.33 times 18.02 divide by 1 equals, and I get my final answer. My final answer, according to my calculator, is 41.9866. That is going to be your number of grams, or the amount of mass, that is 2.33 moles of water. Again, notice the process, the steps are identical. You start with your given, you cancel out that unit by putting it on the bottom right. Then as you go vertical up above it, you have to find a conversion factor, something that you know how to convert from this on the bottom to what goes on top. Once I've completed that, I put in the numbers to represent the conversion. Then I multiply every single number on the top and I divide by every single number on the bottom. In this case, 2.33 times 18.02 divided by 1 equals, there's my final answer. All right, so that's number 4, again, which is an actual proper chemistry problem, which again is going to be more similar to what you're going to see when we get into stoichiometry, well, with a lot more steps. All right, the next one is number 3. Again, I know we're going backwards, but it's a little bit more advanced in that it might require a little bit more, and you'll see why. So what we have here is, it says, convert 50 grams to ounces if 1 pound is a certain number of grams, and some ounces equals a pound. So there is our conversion factor. I'm going to go ahead and do it this way. There's our conversion factor. And then the question, of course, is in front of that. So what we are given is 500 grams. What our unknown is are ounces. So we need to convert grams to ounces of whatever substance we're talking about. I don't have a clue. Here's my little picket fence or railroad track. Again, I already know I need to put my grams down here in order to cancel out, right? Then I'm going to figure out what can I put above grams that I can convert into with confidence. It says in that box that I put in the box that a certain number of grams is equal to a certain number of pounds. So I'm going to put pounds. Now, LB, of course, is the abbreviation for pound. Again, this is Latin, kind of weird, but that's the way it works. So then we have grams to pounds. Okay, but we're at pounds. The question asks, convert 500 grams to ounces. That tells me we are not finished, and we're going to require another step. So I'm going to move pounds down here to cancel out, which means I need something to go above it that I can convert into. In this case, I know that in that box, in the conversion factors that they provided to us, I know how many pounds equals how many ounces. So I'm going to go ahead and put the abbreviation for ounces, which again is OZ. Oops, that's supposed to be a Z. So OZ equals ounce. Again, our very odd empirical units of measurement. They don't make a lot of sense. But we're going to cancel out grams with grams, pounds will cancel out with pounds, and we're left with ounces, which is exactly what the problem asks for. So that tells me I'm done. I'm ready to put in my conversion factors. So looking at the box that I made, I know that for every 1 pound is 454 grams, right? That's what they tell us. I'm just matching the number with the unit. On the right side, ounces and pounds. They tell us that 16 ounces is equal to 1 pound. There we go. All right, so I'm going to pick up my trusty calculator here. I'm going to type in 500 times 1 times 16 divide by 454 divide by 1 equals. I did that in one step. No chance of making mistakes and transposing to paper and then back into my calculator. It's a very long answer, which is 17.62114,537. That's the number of ounces in a gram. Now, we are not going to use scientific notation for this example, nor the previous one, because the number of seconds in 24 hours can't really be rounded. It is exactly that value. The number of grams in moles of water is going to be the true value. In this case, 500 grams to ounces. Again, it's going to be that. Now, if your teacher asks you to do significant figures, let's go ahead and just see what that would be. Let's go ahead and practice. If your teacher did ask you to go to significant figures, then we would look at the problem. The only number we're provided is this one right here. 500 has one significant figure. It's the 5. The 2 zeros at the end are not, because there is no decimal. Therefore, we need our answer on the right side of the screen to contain only one significant figure, because 500 has one significant figure. If that was the case, then we would go ahead and just round all of this up to 20 ounces. That would be the answer in the correct number of significant figures. The top number is the calculator answer. Okay? Again, notice the pattern is the same. It's the same zigzag. Take the unit you start with, move it down to cancel out. Convert up. Take that unit, drag it down to cancel it out. Convert as you go up. Then we put in the numbers last, which is the easiest part. Then we calculate everything across the top. This times 500 times 1 times 16. Divide by 454. Divide by 1. Hit equals once. And you're given your answer in one easy step. All right. This one I like because I like cars. So this one is a little more advanced because, again, we're just adding to the length of it. But the process is still identical. It says a car enthusiast has developed a system for placing values on cars. In their system, one Maserati is worth 3.5 Porsches, and one Porsche is worth 5 Jeep Wranglers. Finally, 2 Jeep Wranglers are worth 15 Ford Pintos. If I collect 225 Ford Pintos, how many Maseratis would that be worth? First of all, I just want to make sure you guys are aware of what is where are the conversion factors. The conversion factors are everything, if I can neatly do this, is everything right there. That's the conversion factor. And then the bottom is the actual question itself. If I collect 225 Ford Pintos, how many Maseratis would that be worth? So my given is what I'm going to start with, 225 Pintos. Okay, I'm going to add my little picket fence. I already know without even thinking much that I'm going to have to carry this down here because that is exactly the process that we do for dimensional analysis. Now, as I go vertical, what can I convert pintos into that could get me closer to my solutions? It says right here, if you look, it says Jeep Wranglers, are a certain number of them are equal to a certain number of pintos. Again, I'm not even reading the numbers because I don't care what the numbers say at this point. So I know this needs to be Jeeps. Wranglers specifically, but I don't have a lot of space. So I know the conversion factors between pintos to Jeeps, therefore I could go ahead and put that above each other because I have the metric or the proper conversion factor. Okay, but we don't need Jeeps, we need Maseratis. So therefore, I already know I'm going to have to cancel out my Jeeps by putting Jeeps down here. Okay, again, there is no shortcut to this. If you're thinking like, geez, can I just skip the Jeeps? You really can't. It's not possible, okay? What I'm showing you is the most simplistic way to do this, and not only that, in my opinion, this is the most simplistic explanation you're going to get. That's just my opinion. All right, then I'm going to look back up here, and what can I convert Jeeps into that will get me closer to my solution? If you look right about there, it tells me that a certain number of Jeeps is equal to a certain number of Porsches, okay? Well, if that's the case, then I can go straight into Porsches. Okay? Again, Porsches, not Maseratis, so we're still not there. So I'm going to have to take my Porsche, move it back down here to cancel out the Porsche. Okay, I'm going to try to continue that line. Then what we need to do, of course, as I convert up, look for something that I can convert Porsches into. Again, if you look right at the very beginning of this second sentence, it says a Maserati is worth a certain number of Porsches. That's a good thing because we're trying to get to Maseratis. We're currently in Porsches, so that tells me I can go ahead and convert from Porsches directly into Maseratis. Okay? All right, so that's the hard part. If you guys could get that far correctly, you're doing pretty well because the next part is going to be the easy part. But we had to go from Pintos to Jeeps to Porsches to Maserati. There is no other way around it. There is no other order. There is no shortcut at all. Sorry, but that's the truth. So now what we need to do is do the conversions. Again, if you look right there, it tells us that for every 15 Pintos is 2 Jeeps. Those are, according to this scenario, equal. That is a conversion factor. For every 2 Jeeps, that is worth 15 Pintos. Again, don't argue with me because this is all made up, but that's just what we were given. The next thing is Porsches to Jeeps. If I look right here, Porsches, it says, for every 5 Jeeps, I get 1 Porsche. 1 Porsche is equal to 5 Jeeps. All right. Next thing I need to look for is a conversion factor between Porsche and Maserati. Again, you guessed it, it's right there. So for every 1 Maserati, that would be equal to 3.5 Porsches. Okay? We already know Pintos is going to cancel out with Pintos, Jeeps cancel out with Jeeps, Porsches cancel out with Porsche. What you're left with is some amount of Maseratis. Okay? All we need to do now is, of course, the calculation, which, again, is really easy if you do it the way I showed you. So I'm going to pick up my calculator. I'm going to do 225 times 2 times 1 times 1 divided by 15 divided by 5 divided by 3.5, hit equals, and my final answer is a lot. It's a very big number. My final answer is 1.714285714. Again, your teacher will tell you where to round or whether they would like you to do significant figures on this particular example. But I do know that if I collected 225 Ford Pintos, according to this scenario, that would be worth roughly 1.7 and some change Maseratis. Okay? Again, the process is the same whether we're talking about grams to ounces or whether we're talking from moles to grams. Whatever it may be, the process is identical, and that's what I want you guys to recognize. The way we're doing this doesn't change. It is the same every single time. All right, that takes me to my last example I'm going to do with you guys. Sorry this video is so long, but I really need to explain this to you. The last example I'm going to do with you guys is number 1, ironically. In this case, what we have, it says, before the use of money, people bartered for goods that they needed. If 25 chickens could be traded for 1 pig, 10 pigs could be traded for 1 cow, 2 cows could be traded for 3 horses, how many horses can be exchanged for 1,500 chickens? Okay? So, really, all of this is conversion. Everything they're giving us is conversions except the very last part. The question actually is, how many horses can be exchanged for 1,500 chickens? The rest of it above that in the box that I just drew is all information we're going to need later. So I'm going to start with our given, 1,500 chickens. Now, chickens is a little hard to write with this, and actually that was the best job I did all day. Okay, so again, I'm going to go ahead and move this down here because I need to get rid of chickens. I don't need chickens, I need horses. Okay, but there is no conversion factor that directly goes from chickens to horses. They don't tell me how many that would be, because man, that would be easy. I'd pretty much already be done. But what I do know is the number of chickens and to how many pigs. 25 chickens for every 1 pig. So this has got to be pigs. And again, that's given to us right there. All right, then we don't need pigs, we need horses. So guess what? I'm going to move pigs down here. Again, there is no way around this. This is not the long way. This is the best and only way. All right, pigs are going to go into something else. We need to convert pigs into something else. If I read what's in the box above, I know that there are a certain number of pigs that can be traded for a certain number of cows. So there's my conversion factor. I know how many cows are worth how many pigs and vice versa. But I need horses. I don't need pigs or cows. I'm going to need horses. So that means I need to get rid of cows by moving it down here to cancel out. And then as I move vertical, I'm going to find something I can convert cows into. If I look above, it tells me how many cows is equal to how many horses. That's perfect because that's where we need to finish. So that tells me that we're finished, and there's our equal sign. Chickens will cancel with chickens, pigs will cancel with pigs, cows cancel with cows. We're left with our answer, which is going to be, I'm going to go ahead and put it way down here, guys, I'm sorry, is going to be horses. I don't have a lot of space, so let me squeeze that down there. All right, here's the easy part. How many chickens are equal to how many pigs? If you read what's in the box, it tells you quite clearly that for every 25 chickens, that's why I put the 25 in front of chickens, is 1 pig. It tells me 10 pigs can be traded for 1 cow. Okay, 10 pigs for every 1 cow. 2 cows can be traded for 3 horses. 2 cows for 3 horses. There we are. So I'm going to go ahead and pick up my calculator, put all of this in one single step. 1,500 times 1 times 1 times 3 divided by 25 divided by 10 divided by 2 equals, there's my answer, a nice round number, 9 horses. In this system, 1,500 chickens would get me 9 horses. Again, it's the exact same process, the exact same technique, canceling out the units, putting in the conversion factors last, calculating using one step, and getting our final answer. All right, guys, again, I do appreciate you guys watching these videos. I hope that helps. And that completes, at least for now, dimensional analysis.